Hello, everybody. It seems like we are live, and I didn't immediately notice that. Today, we are going to implement the to-do app for Near. I mean, in Near, on Near, using Near, Rust, all the keywords. Yeah, I hope it will be interactive, and feel free to ask any questions in the chat on the platform you choose. I think we are live on Twitch, YouTube, and Twitter. I hope Joe will correct me if I'm wrong. And beside that, I think it's going to be just interactive and life experience. So anything that can go wrong will go wrong. Be ready, and I'll go through all the hopefully best practices of building apps on Near in Rust, and a bit of boss components. Can I share a screen? Is it working? Share screen. Share screen. Amazing. So, well, where should we start? I believe we should start with the best portal for developers we have, and that is dev.near.org. And immediately after you land here, you agree with code. That's amazing. We can start from here. The amazing part is that you can build applications in JavaScript end-to-end, the front end and back end. Today also, I will focus on Rust experience, but someday I'll definitely come back to challenge someone to build it in JS and see how the flow compares. But overall, I would say it's not that big of a difference, for good or bad. We'll learn more about it in a moment. So switching to Rust, the very first thing you will notice, if you are familiar with Rust, you obviously know Cargo. If you are not, Cargo is our package manager. And Near is the extension to this package manager implemented by DevHub, and that's where we should start. So if we go to and search for Cargo Near, we will find this GitHub page. And actually today it's all live, you know. Let's check the version. Okay, it's too old. We have to use the newer one. So I'm here on Mac, so I'm copying this thing. That's simple, nice. No extra tooling is needed. It's all one single binary to our disposal. Amazing. So that's our starting point. What should we do? We should start a new project. Hold on, I want to do it from a different folder. It's going to be experiments today. So Cargo experiments. Cargo new. Today it's to do app contract. That's what we want to build first. So it created a folder for us, and we can start from here. Oops, not experiments folder. They're gonna use that amazing thing. Totally recommend. And what we have here is a fully pre-configured project for us. We only left with filling out the repository link, which we haven't created yet. That is a good practice for any contract on chain to provide the source code. So that's the easiest way. We'll come back to it in a moment. So I already know that will be under Frol, and it's going to be to do app contract, or like near to the app contract. Cool. The rest is fine. So this is here for reproducible builds on Near, and we'll come to it a bit later. From the dependencies, we only care about Near SDK. Cool. So let's also jump a little bit back to the apps. To do apps. There are plenty of them, right? Has to be. It's not what I'm looking for. To do apps examples. Let's say I know in React. Cool. Let's see what they're talking about. So create a new project. We are done. Get in the folder and building it. Okay, we're close. We're close. What is to do app in essence? So do we have a screenshot here? There are always plenty of to do apps with this pre-standard UI. No, this one. It's not beautiful. Does anyone remember the proper master beautifully styled to do app? I don't. I'll find it a bit later. But in essence, what we need a way to input a new to-do. We also want to be able to list all to-dos. And each to-do has a status, if it's checked or like it's done or not. We want to be able to edit it. So probably we will need some identifier for each to-do, so like ID. We want to be able to also remove the to-do item. In more complex apps, you can also reorder stuff. We'll see if we want to get there today. What you can also do is change the status, obviously, and maybe like general buttons for like checking all done and filtering by. That's essence. So let's have a to-do of to-dos. So what we're gonna have? Add new to-do, list all to-dos, mark to-dos done, delete to-do, edit to-do. Nice. And we will store all of this obviously on chain. So for that, so we are solving the problem of two things. One is the storage, like where we will store the data otherwise, and also a problem of hosting and serving the data. So we will publish one application, one source code to the near blockchain, and we will basically have two problems solved for us. So this is how it usually starts. So we have our near SDK imported here, and we have our contract with the to-dos. Let's start with vector and think a moment, like just for a brief moment, what it will mean for us. This means that if we will want to add new to do, we can just append it. But if we want to remove, we can find it and remove, but then we will have a problem of changing the index of to do. I wonder if it matters, but that could be our ID of to do. So maybe it's not a good idea. Maybe hash map is a better option. So we would have to do ID and to do. And to do ID will be, so we could use UID or something like that. So let's define to do ID, but I would go with U64. I think it's fairly easy, and we will just increment it as we go. So the to do ID, like next to do ID, equivalent ID would be something that we want to keep in mind as well. So this is the high level. And as we mentioned, we want to have a struct of to do. To do is our what we have. We have text, and we have completed status. It's nice. It's nice. Do we want to keep anything else like removed? So I generally do not like Boolean flags, so I would prefer more descriptive num. So num would to do status with pending or completed is better than true and false thing, and we can always extend it. What we also want, we want to add near here to be able to serialize it for the thing. It's nice helper that just does the thing. Amazing. And so this is our structures. We need, what do we need? When we initialize the contract, I think we want to have some default state. So like, let's go without it first. Let's go without this, and we'll come back to it later. And the implementation, back to the features we defined. Cool. There is a question. Why U64, not U64 with capital U? I presume you are going to want to print the whole item along with the to-do ID. Good point. We'll come to it later. I think we will start this way initially, but that's a good call. I want to. We will see a bit of bad practices first in order to understand the best practices better. Is enum always better to use than true or false? In my opinion, yes. In terms of memory, it's exactly the same. In terms of readability, it's usually communicating the intent much more cleaner, and you cannot suddenly assign, visible to false or and pass that value to status somehow unwillingly, and wouldn't be able to catch the type mismatch error. So I usually prefer, even for to-do ID, I would prefer, we'll talk about it later, not a type alias, but actually a proper type wrapper. Let's get to that bit later. Amazing questions. Let's get them floating. So before we add the to do, we need some new. We need a constructor. We need to initialize our struct, or also in our case, it's a contract state. You can view the contract as a singleton, like the object that you initialize once in the lifetime, and virtually it will live beyond the reboots, restarts of any computers out there. So in contrast to the applications on your local computer, where after a reboot of the machine you have a clean state and clean machine, you need to restart the application from scratch and populated the memory with some data. and your struct would otherwise be blank. When we will upload it to the blockchain, it will be initialized first, and further calls to the functions will operate as if they are as if the application has never been stopped and it was not interrupted. So it's beautiful. It's actually simplifies the development a lot, in my opinion. So, and what we actually do, so add to do takes a mutable reference to self. So we initialize the new, oh, I didn't cover this part. Hold on. So new, our constructor just needs to return the new object of contract. In testing local environment, we can reinitialize it many times, but in the blockchain environment, we only want to initialize it once and not override it in the future. So we mark this method as init, and it will ensure that this method cannot be called multiple times. So after the first run of new function, it will actually also initialize, will make sure that the self is recorded in the local storage on your account here, and that state is what you will then resume from, basically, whenever you run any other function. So let's, I'll cover all those hopefully in details today. So, and the initial state is obviously empty hash map, and the next to do ID will be 0. And to add the new to do, we need from the user, we need the text, and we also want to add it to ourselves. So that's where the self is, and we want to edit it. So the self will be changed. That's why we need to mark it as mutable. And this already gives near attribute here a lot of context about what's going to happen. So let's construct a to-do object. Initially, it will be pending with the text, and the to-do, and we insert it under the key of next to-do ID. We insert the value of to-do, and we do +1 to our to-do ID index. It's a clever trick for those who aren't, like, I think I skipped a few problems ahead. As I mentioned, we could have went with a vector, but then if we would implement deletion, we would constantly lose or like shuffle all the items, and we don't want to do that. So that's how we usually go. You use the hash map with IDs that monotonically incrementing all the time, and then you can remove and create kind of gaps in your collection, but it's totally fine for hash map. List all to-dos. Nice. So that's basically gives. We want to return a vector, a list of to-dos from our storage. So we don't modify the self, so we don't need mute. It's going to be a view method, getter, if you will, if you wish. And I actually want to return to-do ID and to-do. But also it's a bit ugly. Well, what it will give us, right? It's gonna return us a vector of, look, yeah, that's a good auto completion. This is ugly. What's even more ugly is that we will receive it in JSON format, which means that it will be even more confusing, like this. So I don't want to actually do that to me, to you, and to the users in the first place. So what we actually usually want, we want to have to do ID right here. And for that we need, so it's still a vector, but this needs to be a struct. So it's going to be something like to do with ID, but we'll think about it more a bit in a moment. And here we'll want to have like items and do something with the items. Not about code just yet, but let's implement the rest and come back to the cleaning. So mark to do as done. I don't want to actually mark to do, or like better change to the status. Not helping. To this way, change to do status. It's to do ID and status to do status. If there is such to do, so we're getting to do by ID, and we are changing the status to the status. Nice. Deletion. Remove by ID. We need mutable. Here also it's mutable. Edit to do. We want to edit the text if the to do is in the list. So this is a very nice pattern in Rust. I really love this way of guarding basically the operation. So only if there is the actual to do, you can edit it, and you like if let if the return value from whatever is on the right is exists and it's some, not none. So in some there is some value, then we can do something with that value. So and we assign the text to it. Nice. Why not just zero text instead of 20? You can do that as well with just returning the mapping. I'm not a huge fan of making like keeping the ID outside of to do because I'm like what I'm keeping in mind usually is how we will use it. So for this, like from imagine that would be a JavaScript code there, to do's. So let this be to do's. We want to do's to on JavaScript side we would just basically go and return some list of to-dos map, and here to do with to do ID and to do text kind of thing. That's why I personally like this way, but we may also say, okay, we can do object dot entries right over to do's and map what we have to do ID and to do, and kind of deal with this way. Good and bad. The additional benefit actually of this approach is that you have an order. So you have an option to reorder the things, and it would be natural to express it this way. If you go with the ID being a key in the map, then it's like you will need to have an extra separate thing for the order. but the utility that helps you finish the text. So it's some ChatGPT obviously, or like a pilot built into that. It's handy for small and obviously known pieces of code. So yeah, if you are interested, z.dev is the website for the editor that I'm using. Check it out. Amazing thing built in Rust, obviously, and it has everything you need out of the box. Going faster and faster. So what's here? So hash map new. It's time to fix the problems. So let's fix the obvious problems with the compiler instance, and in meanwhile let's also write some tests, because I think that would be more helpful for us. So, the test would be that we can add new to do, and then the contract. So it's you write your unit tests as if it's just the Rust code, and that's the beauty of Near SDK, REST, and JS as well. That it structures everything around structs and classes, and you don't need to think about any wrapping around it. So the contract, what if we initialize it and we want to add new to do, and the text would be write to do app. That's our first to do item. And hold on, what's happened here? And we want to be able to, so, and what we will return get in return, we will get in return a to do. How come? It should return to do ID. And then better to say to do ID equals this, to do ID, and return to do ID. Great. So our newly created to do ID is new to do ID. This. And we want to be able to get it back. So let's check contract get to the text. Did it get to the text? Is it? Did we even implement? We didn't. How come? Do we need a separate method for just one to do? Let's not do that. Let's not do that. Let's just then list to-dos. Yeah, it's a good first test. We will see how we can use more advanced stuff in a moment. Or actually, let's also to-dos. And to-dos 0 text is this thing. Much difference between let some or unwrap or else panic, just whether we want to enter a condition or close the whole function. So panic, unwrap are pretty expensive operations, like, well, comparatively. Ideally, you want to gracefully exit your applications. both in blockchain world and outside of the blockchain world. In near, when you crash, when you panic, you will. So, for example, here, I guess, not here, yeah, but yeah, we could have panicked here, but that would bring not a very useful error message. So ideally, we actually want to return some information to the user. Like, there are different options actually. It's not an STD, but ideally we want to do it gracefully. You can either ignore it, like I did before, like without this else brace. Then it's just silent. If nothing to edit, okay. But we can also communicate that there is some error. And currently in NERSDK errors, there is this abort, or if you want to include some message, panicstar would be a better option to communicate that to do with the to do not found. You can treat it as exit in a way from this particular function. I think now that I'm thinking about it, it's a bit confusing actually. We probably should have a better way to have like return error kind of thing. We actually were working on returning an error result and handling the results properly. That would be the best actually direction to implement it, to handle the contract errors in a sane way. But for now, it's still under implementation, and the error handling, I would say, is not that beautiful today. So our first test is done. Versus started using let some and use return. Do you know it was possible to do construction in card conditions? Yeah, let else is pretty interesting syntax indeed. So we could rewrite this guy into this. It's also, yeah, it communicates the intent very well when you have like a clear like exit condition. So true. I think I prefer this way actually better when we have an explicit like an exit, early exit basically here in the app. Good call. Thanks for sharing. So let's check. What are we missing? Quite a few. Collections, I guess. Okay. Serialize items. Yeah, that's something that we didn't do yet. Okay. It doesn't know about to do with ID. True. Not found in the scope. Yeah, it's fine. Let's do to do with ID. How I would do to do with ID is I would do struct to do with ID. Say it's near to ID tags net. But I would actually to do and apply the flatten. It was there, but Serde is not visible here. Will this work? Really? Let's compile and see what complaints about. Oh yeah, sure. I did I put near, but I didn't say that I actually wanted to implement additional serializer. Serializers should be JSON, and I also want to keep Borscht. That is the binary serialization that is used. Actually, I don't need here Borscht. To do with idea, only return it. I think I need to do it this way. Can you explain a bit more about serialized versus Borscht serialized? Absolutely. So the what we have here, when we store the contract on chain, we need to be able to dump it and restore it while the function is not while the contract is not executed. So for that, we need to be able to serialize data from memory and serialize it back into memory. So for that reason, we need to be able to serialize all the types that we want to store. And we have several options. We could serialize it with JSON, for example, or protobuf, or name it, I know, CSV, whatever. But the problem is, well, we want it to be very efficient, fast, so we could choose. We can say, okay, let's go with protobuf. But then we quickly realized that protobuf actually has potentially different representations of the same data in memory to serialized data, which means that if you run the contract on different machines, you may suddenly, if due to some subtle changes, or if you recompile your program, for example, that is even more triggering event actually, it can change the order of fields. It would be able to deserialize it, but the problem is we need to arrive always to the exactly same byte output in the blockchain environment. That's why we need some stable serialization method. For JavaScript, for protobuf, an object of name, blood, city, world, and the same object but with the fields swapped. From JSON point of view, it's exactly the same. But for the blockchain, we need to be able to hash the data as bytes and arrive to the same hash. So that's why we actually need Borscht, and that's how we arrived to Borscht serialization format in the beginning of near times. Where is Borscht IO? So this is a website. So it's near an engine, if you didn't know. It's actually used in other blockchains nowadays as well, just because this property needs to be there for all of them. It was surprising, and it was so weird to even think about that we in 2018, 2019, we need to build our own serialization format. There has been a lot, like Bean code, a ton of different byte serialization formats, binary serialization formats, but yeah, we had to do it. But the nice part is that it's fully integrated, so for all these structs and the serializations implemented out of the box. As we can see, the to-do requires Borscht and JSON. Why do we need JSON then, right? We need JSON because we want to be able to communicate our inputs and outputs. That was a bad example. Here and here as JSON. So that's how we interact. We submit the requests to the function calls on here. The payload that we send usually is JSON, but it actually doesn't need to be. You can actually tweak, and Aurora, for example, Aurora contract prefers to use bytes as function call arguments and outputs. And it's totally fine from the protocol point of view. It doesn't matter. It's all bytes, but near SDK RS defaults to JSON for simplicity. So it's very easy to review the transactions on chain then. So it's fun. I think we almost done. Check. Items. Yeah, obviously items is not gonna work. Serda doesn't need to be here. Serda is a type modifier that is supported underneath, under the hood here. List. We need to fix list. Then we need to map over to do ID and to do, and return to do with ID, and that is to do ID and nice items. Obviously, yeah, it's either or rather. No, we're not owning this. We're not owning this. Then we need to clone. And in order to be able to clone it, either is a tuple, yeah. To do ID is a reference, yeah. Obviously, we need to convert that one. And clone, it says like to do is not clonable. Again, so by default, Rust doesn't implement unnecessary stuff. So we need to be able to clone to do drive, clone. But in order to clone to do, we need to clone the status. So we need to implement clone for status as well. Okay, only warnings are left. Doesn't recognize that the fact that it's pub. Actually, not here. Huh? Why do you complain? List to do's. Did I forgot? I did. This needs to be pub. This also needs to be pub. It's totally fine. Great. So the checks are passing, so we can run tests. And while it's running, let me cover. So this is the structure layout and the functionality. And we had a few comments already about various things, but best practices. So one thing is I strongly recommend to have tests, but also let's write this test. So this is a small test, right? It's just adding something and then checking exactly the output, but it could be daunting. So I actually recommend using helpers there. And one of the helpers is amazing InstaCrate. So Insta allows you to basically not to write the expected output. Like you only specify the input, and then the input is used and stored in as a snapshot. The output is stored as a snapshot as a file, and then Insta takes care of comparison of the outputs. So we can say we want to assert the JSON output is the same. Let's go back. So how would what I mean is we still do the actions, but here we just say, hold on, Insta, and we don't need to type it out. Let's see how that goes. So, add new to do to our Insta. Obviously, Insta does not unknown field text. What's called? Obviously, I have like in Rust Rust types. I have nesting now, so it's to do dot text. Yeah, new to do ID is not used. That's fine. Insta is not there, so cargo add dev Insta. And I think we need to add JSON there. Nice. So it enabled JSON inside there. Amazing. And then we can run tests. Add new to do Insta. So this is the output. Let me make it bigger. Actually, I should have changed the size of font probably earlier. So this is the, like, it's beautiful. Like, look, I just ran the cargo test, and we are getting one test passed, that the manual one, but the second one with Insta failed. It failed because there was no previously a snapshot to compare with. So we need to actually generate that snapshot first and approve it. So let's run it. So store the new snapshot. That's what it said. And what it makes, it creates a folder, snapshots. Nice. So this is the file. And I don't need to manually now, compare it. And if I, for example, break my code, add new, and I'm inserting not the text, but instead of a text, I would return some nonsense. Then I run tests again. Hold on, I didn't save the snapshot first. Why it takes so long? Oh, it was trying to run the doc test as well. that doesn't make sense. Yeah, we don't need to run doc test just yet. Or rather, maybe just let's remove it. Near budget. Should just generate the file basically. It already generated. So what it says? Insta review. So that's what we need to run actually. And I'm just it asks me if this is the new thing is something that I want to accept or reject. Let's accept it. And then the next test just passes, right? If I change the code and it misbehaves, so it ignores the input when new to do is created, then it says like, oh, old snapshot and new snapshot. This is a diff. It's very easy to review, and if it's something that is expected, it's just a matter of, approving the changes, and that's all. Whereas if I use the old test, let's see. Oops. It just says like, okay, left and right does not match, and how to update it? I need to copy this value. I need to go to the test. I need to find the test. I need to replace it in the test. I need to recompile the tests, and only then the test will pass. So, and if you have a huge output, huge struct, first of all, you don't want to write it down this way. It's just one line. Second of all, you don't want to maintain it going forward. So that's superb. Let's move on to another best practice to mention. So the problem with to-do ID, and thanks Owen for pointing it out, U64 is not something that you can, so where do we use it? Where do we use to-do? We use it here in to-do with ID. And to-do with ID, we return it here. And this is serialized as JSON. So let me show what it actually does. Oh, before that, let's just quickly finish the round with actually deploying it, right? We talk a lot about the code and we still didn't run it. So creating a random account, generating new key pair, saving it locally, fine, testnet. I'm using visitor. Beautiful name, beautiful. Let's now deploy it. Deploy. Where is deploy? Deploy. Yes, I'm using visitor. Oops. It says actually, it's the changes are not saved, and it's your contract cannot be reproduced. And in order to fix that, you better commit the changes to Git, and then it would be all amazing. I'm not ready for that yet. What are my other options? Deploy. I want to be no Docker build. Okay. What's complaining about now? One error. Near default. Yeah, beautiful. So it actually caught the very first and common issue in the blockchain space is lack of initialization of your contract. Sometimes you may forget about the init function, and there is like, or you do have it, but you didn't execute it, and you immediately jumped into add to do, and we need some way to actually prevent that. So you may either implement the default implementation for the trait, or say there is no default for your application state. So derive nearest decay panic on default. That's what we want to do to prevent accidental use before initialization of the contracts. Nice. That was great catch of Rust and ESDK together. We have the contract built, and there are some unused variables. Unused variables. Hold on. That's broken. Another good catch of Rust compiler. Unused, like you should not underappreciate the warnings and linter messages. There is even a famous article about the vulnerability that was pointed out right in the face by Clippy, which is a linter in Rust, and the team didn't fix it before the disclosure of the vulnerability. What is the name of the function? U. And what are the arguments? So what's the arguments that is our functions? Okay. It's new, no arguments. So if no arguments, we can use just, empty object. Let's go with that. We don't need to attach any tokens, and 100 teragas is fine. It's going to be much lower than that, but for our demo, we don't need to worry about it. Anything that is unused, any gas that is unused, even though it's prepaid at the beginning of the execution, anything that is not used will be returned back to you so you will not be charged for the full thing. Cool. We have the contract deployed. Testnet. And it should. So it's what do we have in the plan? So it deployed the contract and executed new. Nothing unusual. But if we go to the account, we see contract. This is the most beautiful part of it. I really love this contract methods. And you see, it's all pulled in through ABI schema from the contract definition. So we have all visibility to the methods that is available from our application. And I want to remind you, we only upload the BASM file. And this is the problem. Like you see, there is no way to view the code. The source code, the Rust code, unless you actually build it in a reproducible environment. That's what I mentioned a few moments ago. So let's see how to fix it. How to fix? So we said like no Docker, and we didn't see. We couldn't see the source code on chain. So for that, another best practice is actually, commit the changes, upload the source code to GitHub, and let's do that. So initial commit, and let's go. Name to the app contract, or near to the app contract, right? This one. Great. New repo, public, yes, great. Remote add, branch, yes, that's what I need. Amazing, let's check. Beautiful, it's here. Now we can build, can we? What I did, like any unexpected error, GitHub XXX, something is still, oh, I didn't save this file, did I? It's overrated. How come? This diff, cargo log. Yeah, I didn't save the file. Oh, but yeah, but it was edited. Hold on, I need to recover this part. Oh, it's actually the tab dependency. Let's try. Now it fails because still the changes are not committed to GitHub. So let's say fix the link to the source code. There we go. Why not implement default for contract instead of custom if you are not passing any args? Yeah, you can do both. It's fine. I find implementing default a bit more verbose, even though it's totally fine way. No strong preference when there is no args. I would say that with like it just makes things a bit easier if you just go always with a new method. It's explicit and universal. If you need parameters, you get them. If you don't, you just leave it empty. So I usually go with not a default implementation, but with a new method. But it's important to have the default that panics then to ensure that it's not causing any security vulnerability problems. Cool, and cargo near deploy once again. Great. A lot of output, but next problem is Docker. I don't have Docker running. Why do we need Docker? So in order to compile the Rust source code to WebAssembly, you can do it on any platform with Rust tooling. It's beautiful, but the result WASM file will be different on every machine due to path difference, due to operating system change difference in tooling changes. So what we did inside Carganeer tooling is we scripted a lot of automation to build the contracts inside Docker images that are frozen and they are not being updated. So you can always go back in time at any point in time on any machine, today or tomorrow, you can rebuild the same source code and get the same result. And that way basically confirm that the source code matches the WASM that is uploaded to chain. And source scan is a service that does exactly this in the background for every contract that is uploaded to the chain. They execute the step, they extract the information from the contract because we encode the information about this image that is built and a bit more of metadata. Based on that metadata, you can download the code, you run the code compilation step, and compare that WASM file is exactly byte to byte, exactly the same as the one that is uploaded to the chain, and integrating that into the near blocks is what allows us to say that the source code exactly is from the trusted source. A bit of a detour and takes time, but it took a while to implement that we do not miss any bits. Especially it's tricky for factories when you need to include another contract inside the contract, and that another contract should also be reproducible. So it's been a challenge, and kudos to Oleg and the team and Andrew for implementing it in Carcaneer and SourceScan, and then the Near Blocks team to adopt it and provide this beautiful UI. So amazing job, guys. Truly stoked on that. So we are compiling. We're compiling in the Docker environment. So it needs to, compile it from scratch again. It should be ready pretty soon. Yay! And we are ready to upload it. Since I'm uploading it exactly to the same account, the state is already initialized. So the the funny part, you remember in the beginning I said that we can treat it as a contract object, as a singleton that outlives anything in the universe. That includes even the code update. So when we will upload the new code, the old instance of the data of this contract is still there, and it can cause problems for people. And the solution is to migrate state. So you need to, before you do any further execution after new deployment, you also need to migrate the old value, old state of this struct and all the downstream structs into the new format. In our case, we didn't change anything on the structure level, so we are good. We don't need to reinitialize it. We just deploy it, and amazing, it's there. So our to-do app is here, right? Let's check. So it will obviously take some time. You can see that it's, you don't see it just yet. I'm not sure. I actually didn't test it on testnet. Maybe it will take a bit longer, or if at all, to have the reproducible build available. But in theory, we can say that it's going to be there. So what do we have? We can add to do. We can complete to do status, edit, list to dos. Let's go with list to dos. Nice, it's empty. How else can we list our to dos? Is from beautiful near CLI. Near contract call function as read only. This is the contract, and we can list to dos. It's you see it also pulls in the available methods automatically for you. It's it feels just right, but it took quite some time to figure it out. This ABI topic and stuff. So list to dos does not have any arguments to it, so it's empty object as parameters, and we say go. Beautiful, empty to do list. Let's add a new to do. How to add a new to do? A contract call function as transaction on testnet. We'll be adding to dos. This is something that I would actually prefer to be also solved in CLI to present the schema of the parameters that we need to pass. So we'll have to. So actually, what NearBlocks already does it, and it's again huge kudos to the team implementing it. So we know that it expects to receive text as a string. Let's test it. We need to test to do app. Connect to contract. Interesting. Okay. Let's try. Do you have any wallet? Import existing account. Create a password. recover account. Let me pull my testnet account credentials. You can't see my screen, can you? Great, let's do it from here then. It's the first time I'm trying here. I'm loving it here. Right, okay. They asked me to sign. What did they ask to sign? Cool, yeah, wow. Transactions, add to do. Beautiful. Enhanced plan, and to do is executed. No logs, result is 0. Is our to do ID is 0. Amazing. Wow. So smooth. Best live screen sharing in my world, in my life. Not this screen, this screen. 2. Let's also add to do from the CLI. Completed here. Text. Test to do app from CLI. Teragas, yeah, we're using very little, so 100 teragas is too much, but I can't hold it. So it's, yeah, it actually, we could attach like 1 teragas. It's super cheap in terms of near fees. And yeah, and then let's check the list of contract, call function, read only, view to dos, yes, no parameters, yes, testnet, no. Boom. Wow. So we're there. We're almost there. Last thing that I want to talk about today is the fact that it's not just, you know, on that website called testnet.nearblocks.io. It's not only on my local machine with near CLI accessing it. It's actually everywhere now. So if we go to, oh, it's not testnet. Why did I should have gone with. No? Is there? Okay, this way. Sign in. It's connecting wallet. Very easy. And I can build a very simple UI right here to my contract. So what I want a list of to-dos. To-dos is near.all or near.view, and the account where I deployed it. Where did I deploy it? So I'm using visitor.testnet. That's my beautiful application name. Now I don't need any arguments to it, so I can leave it this way. And I just want to map it. So do's map to render list of to-do.text. Actually, what I usually do first, I do JSON. It's called stringify. That's my way to actually view the data first to understand. Preview. Map is not a function. True. Let's first do what I just said I do usually. JSON stringify to-dos. True. I'm using visitor testnet. Contract name, method name. Oh, method name. Yeah. I love JavaScript. List to-dos. Beautiful. So yeah, and if to-dos is null, then it's loading. Otherwise, it's this. Nice. So what's left is only say we want to have input type checkbox, value, or actually I don't remember, value checked or checked equal check, something like this. And I also want to do dot text to be displayed here. Input HTML checkbox. Type checkbox checked. Okay, probably just input type checked, checked, or like, let's see this way. What's going on? It's super weird. Let's go even more fun. So in network, we have UI. UI library. I remember it was here. Near UI. Not this one. No, it's not the one that I'm looking for. No way. I was on this page just a few days ago. Oh, here it is. Okay, beautiful. Checkbox. Let's test it out in prod. So this is loading the library, and this is the wrapper, and then the checkbox is this one. Don't care about this one. I only care about this one. Oops. No way. It stopped working. Oh, it's obviously, yeah, it's mainnet, and we are on testnet. Sorry about that. False track. Anyway, something's wrong with the checkbox. That's totally unexpected. If something can go wrong, it will go wrong. Anyway, so at least we have the list of to-dos. We didn't have time to go through the full app with all the features, but something that I want to mention in the closing of it, I guess for today, is that the cargo and near SDK and testing tooling is all there for help, and it's fairly straightforward application that you can build, and once you upload it to the chain, it's just there. You don't need to care about deployment or managing like the load to your application. It's all distributed through the blockchain network, and you can view it as a serverless platform, and treat it this way. So, for example, we have the resource loss project that is also storing the data on chain, and the number of PRs and what the repos that are participating in the race are all available as a like all from anywhere. So it's actually a great way to read on the functions. Probably it expects a bit more data as input, but it's something we can explore here. Box. The tooling is maturing as we speak, so it's if anything can go wrong, it will go wrong. So what's like repos? Interesting. So something is not playing to, like, it's stopped dealing with me right the last moment in any way. Like what the data that we are showing right here with the leaderboard, who owns how much slots points and for which period of time, is all stored on chain, and we have these slots points distributed to contributors or to open source. So it's It's a powerful tool, and fairly easy to manage once you grasp it. That's I guess all for today. Thanks for staying with us, and have a great, lovely weekend. Enjoy and play with Nier, with Karger, with Rust, with Reisosloth, and if you are not participating in Rustoktoberfest, check it out. Thanks, everybody. Bye.